Hi guys, welcome back to YouTube channel Chemistry Live UGPG. Today we are going to talk about carboxylic acids and its derivatives, lecture 6. So this will be highly useful for BSc and BSc chemistry students under CBCS syllabus. So please think for innovation, be creative, learn everywhere, anytime and help to learn others. So this is the syllabus under CBCS syllabus, CC6 paper, semester 3 unit 4, carboxylic acids and their derivatives. So today we are going to talk about Hofmann bromamide degradation reaction, Curtius rearrangement, sulfur compounds, preparation and reactions of thiols and thioethers. So this is the prerequisite knowledge that we must have. So usually the reactant is converted to the product in the presence of reagent. So the thing is how that reactant is converted to the product in the presence of reagent, that is called mechanism. So what mechanism tells us? It shows the movement of double-headed arrow, how bonds are broken and new bonds are formed, leading to formation of product, which may be multi-step or one-step process. So when a bond is broken heterolytically, the atom on which atom the bond is broken, so that gets negative charge with both the electrons, other atom gets positively charged. So the one is negative charge with both the electron, that is nucleophile, and other one is electrophile. So in principle the nucleophile always attack to the electrophile, and as a result you get the nucleophile electrophile bond. So similarly when a bond is cleaved, so you generate nucleophile and electrophile. So now we'll talk about Hofmann bromamide reaction. So what is a Hofmann bromamide reaction? So amide react with bromine in presence of potassium hydroxide to give rise to amine, one carbon atom less than the parent amide, that is known as Hofmann bromamide degradation reaction. So here the structure of amide RCONH2 react with bromine and potassium hydroxide giving rise to RNH2. So in this compound you have one carbon atom less in comparison to the starting material, plus 2 kBr plus K2CO3 plus 2 water. So this is the mechanism. So nitrogen has lone pair of electrons, so it can act as nucleophile. It will attack to the bromine atom and this Br-Br bond will break on bromine. So as a result you generate the nucleophile Br minus with both the electron, and here you get the protonated form of NH2. So again this Br minus will attack to this hydrogen and this NH bond will break on this N plus. So as a result you get RCONH-Br. So again this one react with potassium hydroxide. So this OH minus ion take the proton from here. So you get N minus and K plus, and this Br, it eliminate Br as Br minus giving rise to the nitrine intermediate. So this undergo rearrangement to give rise to isocyanate, and this isocyanate upon reaction with water giving rise to amine plus carbon dioxide. So here is one problem for you guys. If you start with this compound and you treat with bromine and potassium hydroxide, this will be the product. So please write down the mechanism for this one. So one might ask question how this isocyanate is converted to amine. So here is the mechanism. So water, oxygen has lone pair of electron, it will attack as nucleophile to this carbonyl carbon, and this C double bond N will break on nitrogen. So you get this protonated form of this water. So this N minus takes one proton and this OH bond will break on O plus. So as a result you end up with this compound, and this undergoes simultaneous bond breaking and making process giving rise to loss of carbon dioxide and resulting amine. The next is Curtius rearrangement. The conversion of carboxylic acid to primary amine containing one carbon atom less than the acid is known as Curtius rearrangement. So here the carboxylic acid react with thionyl chloride and sodium azide NaN3 giving rise to acyl azide RCON3. Upon heating this one you get isocyanate RnCO, and this one upon reacting with water giving rise to amine, that is one carbon atom less. So this is the mechanism. We know our carboxylic acid react with ionyl chloride giving rise to acid chloride, and this acid chloride can react with sodium azide giving rise to acyl azide. And this is the structure of acyl azide, N minus, N plus, and here N double bond and COR. So when this N minus will come back, this N double bond will break on nitrogen. So here this N minus will come back here, this R will migrate to this nitrogen, and this N bond will break on N plus. So resulting the loss of nitrogen molecule. And the product is RNCO. And this upon reacting with water giving rise to RNH2. So this is the mechanism how this isocyanate is converted to amine. So water lone pair will attack to this carbonyl carbon, and this CN double bond will break on nitrogen. So you get N minus and this protonated form of water. So this N minus take the proton, and this OH bond will break on this O plus. So as a result you get this intermediate, and upon simultaneous bond making and bond breaking process takes place, resulting the loss of carbon dioxide molecule, and the ultimate product is amine. The next is sulfur containing compounds. So preparation and reactions of thiols, thioethers and sulfonic acids. So this is the compound called alcohol, ROH. So if we replace this oxygen with sulfur, that becomes RSH. So that is called thioalcohol or thiols or mercaptans. Similarly, this is the compound known as ethers, ROR. So if we replace this oxygen by sulfur, that becomes RSR. That is called as THIOETHERS or dialkyl sulfides. Similarly, this is the compound called aldehyde. So if we replace this oxygen with a sulfur, so that is called thioaldehyde or thiols. This is the compound called ketone. So if we replace this oxygen with a sulfur, that becomes a thioketone or thiones. And this is the compound called acid. So if we replace the sulfur with a oxygen, so that becomes a thioacid. Similarly, other sulfur containing compounds are, this is RSSR disulfides. Then RSOR, that is sulfoxides. RSOOH, sulfinic acids. RSOSOOH, sulfonic acids. Similarly, RS double bond OR, that is sulfones. So next is the preparation and reactions of thiols. So first we start with alkyl halide. If you react with potassium hydrogen sulfide KSH, you get RSH. Similarly, if you treat alcohol with P2S5, that becomes RSH, thiols. Similarly, RMgX can react with sulfur, giving rise to RSMgX. Upon hydrolysis, it gives RSH, thiol. Then reaction. Thiols can react with sodium, giving rise to sodium mercaptide, RSNA. Then ketone can react with RSH, thiols, giving in presence of acid catalyst. You get the protected form of a ketone. Then preparation and reactions of thioethers. So if you start with alkyl halide and you react with K2S, you get RSAR, thioethers. Similarly, ether can react with P2S5, giving rise to RSR, thioether. Similarly, RS whole twice Pb, if you hit that, you get this thioether. Then reaction. RSR, thioether can react with bromine, giving rise to dialkyl sulfide dibromide. Similarly, thioether can react with alkyl halide, giving rise to trialkyl sulfonium halide. Similarly, thioethers can react with water and sodium hydroxide, giving rise to alcohol. So please subscribe to our channel Chemistry Live UGPG. So this is also available in the website www.chemistryliveugpg.com. For class 11th and 12th standards, this is the channel Foundation Chemistry AV. This is also available in the website www.foundationchemistryAV.com. So this is a simple step towards e-learning, making life better. Thank you all for learning.